When we think of discovering alien life, our minds almost immediately shoot right up into the stars, don't they? But what if I told you that the darkest, most terrifying, and literally the most crushing depths of our own oceans actually hold the ultimate secret to how extraterrestrial life might exist? In this explainer, we're unpacking the biological baseline of the abyss. We're going to explore the fascinating science behind deep-sea mysteries and discover exactly how biology completely defies the extreme, violent physics of the deep. So get ready, because the answers here are as brilliant as they are terrifying.
Okay, let's dive into this. It's honestly a staggering juxtaposition. We actually have better, more comprehensive maps of the surface of Mars, a planet millions and millions of miles away, than we do of the abyss right here on our very own homeworld. We spend so much of our time charting the cosmos, constantly looking up, that we kind of forget about the massive, completely unexplored frontier right beneath the waves.
And when we finally do peek into that uncharted abyss, we find the stuff of literal ancient myth. Down in the absolute pitch-black environments of the ocean floor, there are these superheated vents, and they are violently spewing out minerals and scalding hot water. Researchers often describe these hostile zones as a gate to hell. I mean, it sounds like something straight out of folklore, right? Yet it's a very real, very physical place on our planet. Defying all logic, bizarre, completely alien-like organisms are thriving right there in these superheated extremes, just totally shattering our conventional understanding of where life can even exist.
So this brings us to a really fascinating intersection of ideas. To truly wrap our heads around the deep sea, we have to merge forbidden places mystery with natural disaster physics. Think about it. The deep ocean represents the ultimate forbidden place. It's a dark, unreachable mystery that humans have naturally feared for centuries. But the conditions down there are so unbelievably harsh that just existing in that space means battling violent forces that are totally on par with the most devastating natural disasters we see up on the surface.
Now, the dominant physics of that environment is extreme pressure. If you were to travel all the way down to the bottom of the Mariana Trench, the crushing weight of miles of water above is actively pressing down on you from all sides. To put that into perspective, it's roughly equivalent to having a full-grown elephant standing on your thumb. Yeah, an elephant on your thumb. It's basically a continuous, violent, natural disaster happening in slow motion every single second, effortlessly destroying almost anything engineered by humans.
Now, what's really interesting about this slide is just how clearly it shows the difference in survival strategies. Imagine subjecting a human pelvis to that environment. Because human bones are dense but structurally contain vulnerable air pockets, the extreme physics of the deep would cause them to instantly and violently shatter. They'd just simply implode under the crushing weight. But then you look at a deep-sea squid and it navigates that exact same terrain effortlessly. Why? Because its biological architecture is completely different. It's composed mostly of water, designed specifically to survive this total nightmare of an environment.
So, the crucial point is that the biological solution is beautifully simple. No air pockets, no implosion. The deep-sea environment instantly weaponizes empty space. By simply lacking the fatal air pockets that destroy rigid structures, these deep-sea creatures manage to bypass the single most deadly technicality of their environment entirely. It's almost like a cheat code for extreme survival.
And this brilliantly illustrates nature's ultimate workaround. This physiological makeup, being primarily composed of water and entirely devoid of compressible air spaces, is just genius. Because water itself is relatively incompressible, the organism basically matches the density of its environment. It doesn't fight the crushing depths with heavy, rigid armor. It survives by becoming one with the water itself. Honestly, it is an absolute masterpiece of evolutionary engineering.
Let's move to and see how this builds into something even bigger. This is where a biological earthly marvel becomes a scientific Trojan horse. Think about it. If life on Earth can perfectly adapt to crushing pressure, total darkness, and superheated vents simply by utilizing water and ditching air pockets, what does this mean for other planets? If life can thrive in an environment we once thought was a guaranteed death zone, well, it completely shatters our assumptions about where else in the universe life might be hiding. This really forces us to powerfully reframe our own oceans. The abyss is no longer just this spooky, dark void at the bottom of the map. Instead, it serves as a biological baseline. It establishes a rigorous scientific model for the absolute limits of biology itself. It proves, beyond a shadow of a doubt, exactly how life can persist under the most extreme survival conditions imaginable.
And when we take that baseline and look back up at the stars, the connection is breathtaking. Take Jupiter's moon Europa, for example. Scientists strongly believe this icy moon hides a massive, deep ocean of liquid water right beneath its frozen crust. The harsh, lightless, high-pressure conditions in Europa's hidden ocean could be incredibly similar to the bottom of the Mariana Trench, meaning our superheated ocean vents and the water-based creatures surviving there, they serve as the absolute perfect scientific model for how life might actually exist on harsh, distant worlds millions of miles away.
So the mysteries of our deep sea, once thought of as these terrifying, forbidden places, actually hold the keys to astrobiology. We mapped Mars, but by exploring our own unmapped depths, we found the baseline for cosmic survival. Which leaves us with one awe-inspiring question to consider today. When we finally crack through the ice of a distant moon, is the first alien life we find going to look just like the creatures swimming in the terrifying depths of Earth? It's wild to think about. Keep wondering, keep questioning, and I'll see you in the next explainer.